Hello, everyone. I am Wang Puland, an instructor at Huawei. Previously, we discussed troubleshooting for when STAs have no signal. Next, we will look at troubleshooting for cases where the terminal signal is weak. If the signal is weak, it is often a problem at the physical layer. This could be an issue with the antenna, or possibly with the terminal itself. Right, it could also be an issue with the transmission power. First, let's examine if the AP's transmission power is low. If so, the AP may not be suitable for this scenario. Its transmission power is too low. Or there could be a fault causing the low transmission power. Occasionally, the AP should have a power of 100 milliwatts. That is, a signal strength of 20 decibels. The second scenario involves APs with external antennas. The antenna could be loose or not connected at all. A loose antenna is a common physical phenomenon. It is quite easy to troubleshoot. What else could be the problem? It could be that the cable is too long. This is something to be aware of. What problems can occur if the cable is too long? It can cause severe attenuation of the signal. Therefore, we recommend that the cable length should not exceed 80 meters. The limit is generally 100 meters. Of course, a good quality cable might support a bit longer. But it is not advisable to lay the cable that long. Additionally, outdoor APs may use feeder cables. You need to be aware of the feeder loss, because feeders come in many types. Feeders vary in thickness and have different optical or electrical resistances. So you need to consider how severely the feeder affects the signal loss over its length. The third scenario is on-site issues. For example, if there are obstacles between the terminal and the AP. If there are obstacles, the signal attenuation can be quite severe. Currently, the wall penetration capability of APs is relatively average. To date, no APs have shown effective methods of penetrating walls well. Wall penetration is still acceptable, but concrete walls are a major concern. Concrete walls contain rebar. Rebar is metal. This makes the situation difficult, because it significantly attenuates the signal. This could result in very poor signal quality. The fifth issue is terminals connecting to distant APs. The customer perceives this as the terminal showing only 1 or 2 signal bars. Right? They know today's Wi-Fi signal is poor, just 2 bars. What should my response be? Is the user not connected to the AP in their room? Instead, they've connected to an AP upstairs. Hence the low signal strength. Maybe the AP in their room has malfunctioned. So, check directly if that AP is working normally. Is it due to connection to a remote AP? Finally, there might be individual issues. The terminal itself might also have some problems. That could lead to these symptoms. These are common issues with weak signals. Earlier, we mentioned obstacles. They cause signal attenuation. Let's look at some typical obstacles. Regarding obstacles, first, we consider the material. Whether it's brick, metal, wood, or glass, we need to have our own understanding. Secondly, the thickness. Signal attenuation correlates with thickness. The thicker the obstacle, the greater the signal attenuation. For example, a 40mm thick wooden door causes 3 decibels of attenuation. Metal, say it's 80mm thick. Then it would cause 30 decibels of attenuation. Concrete, that's 240mm thick, would cause 25 decibels of attenuation. Attenuation is quite severe. Be aware of 25 decibels. 30 decibels of attenuation is very significant. Our total signal output is only 20 decibels. For example, after transmitting over 1 meter, there might be a 40 decibel milliwatt loss. And if there's another wall, I'll have to account for another 25 decibels milliwatts of attenuation. Now, how much is it, right? It's a negative 45. If it's 2 or 3 meters, then it could be even lower. This is something to be mindful of. The attenuation of 5 GHz signals is even more severe. Everyone should have an understanding of this at home. If the output is a dual frequency signal strength, you'll often find yourself connected to the 2.4G network, because the 2.4G signal might be stronger. It's suggested to use one SSID for the 2.4G signal and label the 5G separately. Then connect to the 5G when possible, as 5G has a faster speed, right? This is a common issue. Everyone should be clear on this. In our upcoming deployment course, we will explain in detail about different materials and how to use them, and also about the troubleshooting process. First, check if the AP's transmission power is too low. Then, if the antenna installation on the AP is correct, check if there are obstacles between the AP and the terminal. See if it's possible to connect to a remote terminal. Check if there are any issues with the terminal itself, etc. These are all considerations for our reference. Another issue is weak signals. What else could be the problem? It could be severe interference. Severe interference definitely has an impact. Because some devices are too numerous, they have already caused a significant impact on your transmission power. Your power is also unstable. Sometimes the signal strength is very high. Sometimes the signal strength is very high, and then sometimes it is very low. Previously, we did a project for Burger King where the signal experienced a drastic drop. This means the signal coverage was not very good. Usually, there's no issue, but every hour or so it would suddenly drop very low. For example, it was at negative 50 decibels milliwatt, and then it would disappear, down to negative 80 decibels milliwatt. It just plummeted. Later, we looked at the on-site scenario and found too many APs nearby. Previously, there were 3 channels, 1, 6, 11. Channel 1 might have had 30 APs, and channel 11 could have 40 APs. This was difficult to manage because it was a shopping mall. Malls are a special case, since there are so many stores inside. Each store sets up its own SSID, and some places even set up 2. This leads to each store emitting a signal that might not be very good for you to use. There are restrictions and interference, which can cause the signal to become unstable or to decrease. Let's look at other problems. One is outdoor scenarios. It could be AP antennas or serious obstructions around, like trees, walls blocking. And when outdoors, perhaps the trees are quite tall or the buildings are high, resulting in lower signal strength. Typically, when deploying outdoors, we need to consider the height of obstacles and their impact. We consider these scenarios when planning. Another reason could be devices like microwaves or Bluetooth headsets causing interference. Then there's the position of the terminal, directly in line with the AP's antenna, with obstacles in between. This is caused by obstructions. Then there's the Wi-Fi signal indoors. To save money, a common solution is to place many APs along a corridor, then use the corridor's APs to cover the devices inside the rooms. This experience is very poor. This approach was commonly used in which scenarios? In university dormitories. Dormitories are the most common places for this, because it saves money. For example, replacing one AP could cover 6 rooms. In such cases, consider the open plan style. You can see there's a big problem with the number of rooms covered. Why, for example, in this diagram on the left, there is 1 AP in the corridor. If it reaches the rooms, it might have to penetrate 2 120mm brick walls. The signal attenuation is still significant. Generally, it is not recommended to deploy in this corridor covering manner. Currently, the use of agile APs is recommended, using a central AP method with RRU to cover the rooms. The second scenario is the same. AP signals passing through 2 walls is not recommended. Okay, the third scenario is installing APs into suspended ceilings. Everyone can take a look. Many companies' ceilings are made of metal panels. They don't want to mount the APs outside because it makes them feel unattractive. In this scenario, if it's placed inside the metal panel, it's very bad. Although it's just a thin layer of metal, the signal attenuation is very serious. It also affects the network signal strength, so this is also not recommended. These are some common issues indoors. For outdoor scenarios, when planning, firstly, the coverage distance of a single AP should generally not exceed 150 meters. Usually, what happens is, when we adjust the directional antennas, when using directional antennas, you generally reach the limit. For example, with a high-quality laptop, it might reach 300 meters. But when planning, we usually don't plan for 300 meters, because it's not very stable. Around 200 meters is more realistic. 150 meters is a normal radius. The coverage radius of an AP should ideally be 150 meters. If you're using an omnidirectional antenna, the range should also be 150 meters on the other side. So together, that makes a 300-meter diameter. But generally, we place an outdoor AP every 75 or 100 meters. Also, outdoor APs have an additional issue, the presence of trees. We use a concept called the Fresnel zone. This is considered when deploying outdoors, which takes into account the impact of trees. This is considered when deploying outdoors. But currently, outdoor scenarios are rare, and such applications are also limited. So, we won't go into much detail here. The next issue is the AP installation height. For AP installation, if, for example, it's installed higher than 15 meters, there isn't an exact rule, as it depends on the specific scenario. If it's installed at 15 meters and you want to cover an area below, how should you cover it? Which area do you need to cover? You need to check if the specific area is covered effectively. Sometimes there might be obstacles below that require the AP to be mounted higher. There's no way around this. Finally, the installation direction of the AP. APs come with various types of antennas, so installation location is also crucial. What should you avoid? Avoid interference between APs. Sometimes, when installing outdoor APs, two APs might be placed close together, especially when it comes to the antennas. There can be back-to-back antenna installations. With these installations, you have to consider how to position them properly. These are some issues that come up with outdoor AP installations. The last issue is the performance of the terminal. This can cause poor AP signal reception. The terminal's performance might not be adequate. Generally, a laptop performs better than a mobile phone. So normally we use a phone for testing. If the signal on the phone is poor, then test with a computer. This can give you a general idea of whether the phone's reception capability is weaker. This is a common issue with air interface signals that causes some problems. In the next lesson, we will start discussing troubleshooting issues related to slow internet on terminals. See you in the next lesson. Thank you, everyone.